So welcome everyone. So myself Shweta, I'm a mechanical trainer in EduCAD. So today we are going to uh, learn about the basics of the CAD. So that too mainly in mechanical. Okay. So before going to that, we are our EduCAD is a very old center for the quality education. So we will train not only the mechanical softwares, and we will also train this what are the civil softwares. Okay, and we work on this IT also. So we have our digital marketing. So we have a well trained uh, trainers for the particular departments. Okay, so I am from the mechanical. So let us start with the CAD mechanical. Okay, so let us start with the introduction of CAD. Okay, so what is this CAD? So what all the things we are going to learn in this CAD? Okay, so here this is the table of contents what we are going to learn in the CAD, that what is CAD and what all the process which will carry out in the CAD drafting. Okay, and what is the application of CAD, that too in mechanical engineering. Okay, in the mechanical engineering department, what all the machines or parts, whatever which comes. So what are the applications, where exactly we will use this CAD in mechanical. Okay, and what are the advantages of CAD? So over manual drafting. So if you compare manual drafting against this CAD, so what are the advantages of CAD? And next is your introduction to AutoCAD, and I'll just give a brief introduction about this SolidWorks also. Okay, so we have other CAD softwares also other than this AutoCAD. We have an XCAD and Fusion 360. We have a Solid Edge and SolidWorks for this 3D drawing. Okay, so let us learn about what is CAD mechanical. So as you all know, so CAD stands for a computer aided design. So initially we will be drawing, designing the parts or the assemblies will be by the 2D only, by using some mini drafters or the drawing sheets. On the drawing sheets we'll be using that mini drafters, and we'll be drawing those 2D drawings. So once the CAD started, so it became very easy for us to draw the 2D or 3D, and it is very easy for dimensioning also. Okay, so that is what we are using the computer for designing the 2D and 3D software. So that is why we call it as a computer aided designs. Okay, so we have a specialized CAD software for the mechanical design. So for the mechanical, it is a different CAD softwares, and for the civil people also they will use CAD. So that is a different thing. Okay, and for the electrical we use a different CAD softwares. Like it is all the same. The name it is all same, but what are the features which is available in that software? It is different. Okay. So and next, what this CAD exactly do? Okay, so we will be using that CAD software for creating and modify, analyze and optimize the designs. So if we start drawing the 2D drawings, so first we have to create the drawing. Okay, so next we will modify using like dimensions. So if you want to modify the certain things from say for example, if you want to modify the length of the part, okay, say like from 80 mm to 100 mm, you can modify it by using the dimensions. Okay, and next, once the part is created, we will send it for the analyze. Okay, so the analysis will be done whether it is exactly matches the drawing what the salesperson is given. So then it is optimized. Okay, so if it is not matching the sales requirement, sales person requirement, then it will be optimized. Okay, so here it is. First the parts, we will create the parts, machine parts, then we'll do the assemblies. Okay, the same part assemblies we will be doing, and final the industrial equipment will be get ready. Okay, next is here you can see the mechanical part example. Okay, so this is the isometric view, and this is your front view, top view and side view along with the section we have taken. And this is the process of the CAD, what exactly in the process happens. Okay, so here you can see there is a recognition of need. The first step of the CAD process, it is recognition of need, and next is your definition of problem. Next will be send it to the synthesis, then that particular part will be sent it to an analysis or optimization. Next we will do the evaluation, and then final the presentation. Okay, so here what is the recognition of need? Okay, so here you can see the first step, recognition of need. So this recognition of need is nothing but the salesman will give us a drawing or the design. Okay, current machine design to modify it. Okay, if he want to modify the current machine design, he will give some different dimensions and all. So that is his requirement. He want to modify the current machine design, or if he want a new part to be designed, that will be also his requirement. Okay, it might be a new design or it might be a current design modification. Okay, that is by the whatever the requirement we will get it from the salesman, it is we call it as a recognition of need. Next is your definition of problem. So what exactly the definition of problem? Here once we take the demand design, we will just look into the specification of the item or design, how it is to be done. Okay, what exactly the dimensions is given, whether it is in inches, millimeter and all. And not only the dimensions, it includes all the functional and physical characteristics. See what all the functions, so where exactly that part we are using, and what kind of materials we have to use it to make that part. Okay, so and what is the cost, what is the limitation the salesman he has given. Okay, and the quality, what he is expecting, what kind of quality he is expecting, those things, and the performance. So for whether it is a small part for the small equipment, so based on that the performance will change. Those things will be included in this definition of problem. Okay, so next step is the synthesis. Here you can see the what is that design process, exact design process. Okay, so what exactly you are going to do here? So you will get the requirement from the salesman, and you will get the problem definition from him, and later on you have to decide when to start, which part to start, and where exactly we have to start it. Okay, so whether you have to start from the base or from the length or from the circle or extrusion or all these things, we have to decide while doing this synthesis, while selecting the design process. Okay, so next step is to analyze and optimization. So once the design process is uh, done, so next, so we will design the part as per the process or the definition what they have given. As per that, we will be designing it. Next, we will send that design to an analysis process. So where exactly, what exactly happens in the analysis? We will do the suitability test. So what exactly you have created the part, that part whether it is whether it suits the requirement, whether exactly it is what exactly the salesman given, no. So that part and that definition whether it is matching or not, based on that we will analyze it, and if it fails, if the design fails to satisfy the salesman requirements, then it will be more resend to the redesigned, it will be redesigned from the starting again. Okay, so that process will be repeated until the design will be accepted by the salesman. Okay, so next that will be optimized. So nothing but you are repeating the iterative process for designing the same part until he accepts it. Okay, next we will send it to the evaluation process. So here we will start creating a prototype or a model. So till this time, till this analysis or optimization, we will be creating only the drawing of the 2D part or the 3D part, whatever. Okay, so here in the evaluation, once all the drawings is accepted, then we will create the prototype of it. Okay, that 3D part we will be creating, that a small 3D part we will be creating, and that will be sent to a performance and the quality test and all. Okay, if that is done, if that test it is uh, good, if it is an acceptable test, then we will finally present it. The final process, it is nothing but we are documenting all the things, what exactly the design is and what is the material we are using and what are the dimensions, and what is the result of the performance or the quality test, everything. Okay, everything will be documenting, and finally we will assemble it. This is what is your presentation, and this is how the structure flow in the CAD. Okay, so next it is your assembly drawing. Can you see this assembly drawing? This is your 2D drawing. Okay, so we are taking some bolt, nut and washer, a simple assembly of bolt, nut and washers. Okay, so here this is your nut and this is your bolt and this is your washer. Okay, on the bolt they have mentioned some thread. Okay, and this is what is your 2D drawing, bolt nut assemblies 2D drawing, and here it is exactly how it is visible to us, like the final assembly. Okay, in 3D, and once we explode the assembly we will get like this. So that will be mentioned in the while drafting in the drawing sheets. Okay, so that we have to mention it, like we have to label that parts like 1 2 3 and all. We have to give that numbers and we have to label it in the explode view. Okay, so next is what is the uh, ha, so you can compare the hand drawing and this CAD drawing. So which is more appropriate drawing, or the or what we call which is more easily understanding kind of drawings. So earlier days they will be doing this hand drawing by using some mini drafters and the drawing sheets and all, pencil scales and all. So while drawing this hand drawings, see you can see this here there is a hand drawing and here on this side it is a CAD drawing. So which is more attractive? Obviously the CAD drawing, right? Here it depends on the person to person, skilled person. Okay, so here they have mentioned some diameter or whatever that or units or the circle or the position and the dimensions, angle, everything they have mentioned it, but it is not that clear if you compare to this CAD drawing. Okay, it looks very clean and neat. This CAD drawing looks very clean and neat. In the hand drawing, they will be like all every skilled person will put their effort, but still it is not comparable for the CAD drawings. Okay, so what are the advantages of CAD's drawing over this manual drafting? Okay, here you can see based on the method we will be comparing the hand drawing and the CAD drawing. So in the hand drawing, you know, we will be using pencil, scale, drawing boards. Okay, so we'll be using all these things and we will draw it by manual. And here it is a digital creation. And next, accuracy. So accuracy, it is in the hand drawing, it is depends on the skilled person who is drafting the drawing. Okay, here it is very precision. The CAD drawing, which is digitally created, so it is very precise and the dimension will be very exact. See, while using this scale, so you could have done here and there while doing the measurements and all. You could have done here and there by you. See, if you are using very thin sharp pencil, then only you can draw an accurate, very small what is that, dot and all. But here the CAD drawing, it is very precise. Okay, and time required. So hand drawing, it takes more time, but compared to the CAD drawing. Okay, so in this computer we can create it in a minutes and we can edit it very quickly. Okay, and modifications, you know, so we can't do in the hand drawings, so we have to erase it and we have to redraw it again, it takes more time. So but in CAD drawing we can edit it in a minutes or in a seconds, like that we can edit it. Okay, and storage, this hand drawing storage is very bad, so we have to store it in paper. Okay, and it will be not long lasting, like you can't store it for an years. Okay, so here you can store it digitally so that it can be stored years together the same way as it is. Okay, sharing and hard copy sharing only in the hand drawing. Okay, and here it is, we can share it through the emails or what is that, cloud sharing or whatever. So this will be very easy. Hard copy sharing, it will be difficult and we can't if we want to share it with the other person who is too far, then it will be very difficult to share and it takes time also. So 3D modeling, you know, in that sheet we can't do the 3D modeling. In CAD drawing, it is very easy to create a 3D model. And reusable. See, once the sheet it is misplaced, then we have to draw it again. Okay, so we have to do it again and again. So once we lost that hard copy, we have to do it again and again. We have to redraw it. But here we can use the same model and we can create it as a template and we can reuse it. Okay, so next, cost. In the hand drawing, it is initial cost is very less, but the maintenance will be very high. Here it takes higher, the cost side it is higher on the CAD drawing initially. Later on it is compared to an hand drawing, it is less for the maintenance. And error creation correction, it is like it is kind of time consuming, we can correct it very easily in the CAD drawings. Okay, and what are the applications of CAD in mechanical engineering mainly? Okay, so applications of CAD, it is vast. Okay, but in mechanical engineering we have taken some more examples over here. Okay, so we can design the machine designs and we can use that CAD in the automotive components, aerospace industries, and in the manufacturing industries and in 3D printing. Nowadays it is very booming, 3D printing. So these are the applications of CAD in mechanical engineering. So you can see this gear assembly and this crankshaft and the piston assembly, and this is aircraft. So this is your 3D printing. These are the applications of your CAD in mechanical, mainly in mechanical engineering. Okay. So next, what is the, so till this time we have learned about the CAD. That's it. So CAD is nothing but computer aided design. That's it. And next we are moving into the software. What all the available CAD softwares we are using in this mechanical field. Okay, the first thing is your AutoCAD. AutoCAD is a software which is developed by the Autodesk. Okay, here we can create the 2D drawings and the 3D models in all the fields. Okay, in engineering and in the architecture and in the construction, wherever, like in civil also we are using. That is what we have mentioned here, architecture and construction and all. Okay, so here first in the mechanical engineering we will be creating like AutoCAD. In AutoCAD only we will be creating first the part drawings, then we will do the assembly drawings, then we will take the drafting layouts. Okay, so this AutoCAD, it is first released in 1981. It is the most popular drafting tool in the world because small companies, they are using AutoCAD. Not only the small companies, if they are companies, they are doing a small parts, then they will use the AutoCAD. It is very easy to use. Okay, so this is what is your AutoCAD user interface looks like. Okay, so here are some toolbars we have mentioned. Okay, so this is mainly the title toolbar. Okay, title bar, here we will mention drawing name. If we are using the first drawing, it is mentioned as drawing 1. Okay, we are doing the first drawing, it shows we are doing the first drawing. And next is here pop menu. Pop menu, it is here, it consists of file, edit, view, insert, format and all these things. Okay, next is your layer toolbar. Here we will be creating the layers for different parts. One part will be done in one layer and other part will be done in other layers, and the assembly will be done in the fourth layer. Like that we can do it in the layer toolbars. Okay, by using this layer toolbar. And the next is your standard toolbars. Okay, this includes all these kind of the calculations, zoom in, zoom out and all this kind of things over here. And object properties toolbar. So whatever the object we are selecting, uh, those properties will be given here in this object properties. Okay, and the styles, you know. So if you are styling that particular part or a particular line or particular command, then you can use this style toolbar. Here is your modify toolbar. Okay, see, if you want to modify certain things, if you want to rotate that and if you want to pan it from one place to another place, if you want to plan it, and if you want to look at the dimensions and look at the structure, then you can use the modify tools. Okay, here you can not only those things, here you can find many other things also. Next is your communication center. Here we will be communicating the drawing. See, what is the what is that, what kind of dimensions we are using, it is in mm or it is in inches, everything will be decides in this communication center. And this is your status bar. What is the status, we will be checking over here in the status bar. So this is coordinates display. So if you start moving the cursor, then you will come to know how the coordinates will be changing over here. Okay, and this is the command prompt window. Here we can directly give the commands, or you can directly select it over here, this drawing toolbar or the command toolbar. Okay, so this is your UCS icon. Okay, so and next is your models and the layout tab. Okay, so these are the things, and this is mainly this black screen, we call it as a drawing area. Okay, here you can see this cursor here, that is plus. symbol, it is nothing but your cursor here. Okay, so this is what is your AutoCAD user interface looks like. Okay, so you can see over here what are the basic commands in AutoCAD. So if we use the line, again in the line there are so many types like line from point to point, and one point it is a array, what is that, arrow mark, and one other end will be a point, like that we call it as array, and XL line, and rectangles, polygons, everything comes under this commands. Okay, next is your like circle. So what are the kind of circles? Circle, arc, ellipse, those things will comes under this circle command. Likewise, we'll be using this polygon. Again, polygon, in the polygon we will be taking this pentagon, hexagon, and all will comes under this polygon. Okay, so next is your trim, offset. If you want to cut down some line, then we can use the trim. And if you want some the line to be shifted to some distance, then we can use the offset. Okay, and dimensioning thing, and we can hatch it. Hatch it is nothing but we have to mention certain length will be different, and other remaining part will be different. In that way, we have to show that distance as a we will mark the distance as a hatching. Okay, so by using hatch command you can hatch it, and you can separate the part. Okay, so next is your what all the top CAD softwares, as I said before only. So we will be using AutoCAD, SolidWorks, Solid Edge, CATIA also, Fusion 360, and Creo, Inventor, NX. Okay, these are the softwares which is available in the market for the mechanical design. Okay, so this EduCAD is also offering all these softwares. Okay, so all the softwares will be available in the EduCAD. So what are the career and income opportunities for a CAD engineer? So initially, see, once you know the CAD softwares, you can be a design engineer. You can start designing the parts over here, and you can be a design engineer. Next is your aerospace. In the aerospace also, we need a designers for creating the aircraft designs, and electrical engineers, electrical CAD engineers, and the drafters, CAD CAM application, and the freelancing CAD designers. He can become a freelancer also. Okay, so these are the career opportunities for the CAD. Okay, so if we move on to some analysis, so there analysis software, then there is a opportunities on the analysis field also. Okay, so after the CAD, what are the skills uh, you should be going to learn? It will make you proficient in the design. It is nothing but your CATIA, Creo, SolidWorks, and Revit and all. Okay, so this is what is your CAD introduction. Okay, and next is like your SolidWorks. SolidWorks, it is 3D modeling. So there, this SolidWorks mainly we will be using for the 3D modeling. Okay, and this CAD it is for 2D. AutoCAD it is for 2D. So most of the companies they will be using the SolidWorks for the 3D modeling. Okay, it is all like the user interface will be like this only, like or drawing toolbar, status bar, and your title bar. Okay, and what is that, modification bar, and this pop menu bar and all. So all these things will be the same, little difference in the SolidWorks. Okay, so uh, hereby I'll finish the CAD introduction. Okay, thank you.